So welcome back again, students. We were studying about functions. Clear? So in the previous class we have studied constant function, identity function and modulus function. Clear? So as I said in the previous class, in the next class I am going to take polynomial function. So that's why I am going with polynomial function. Clear? So this is also one of the real valued functions. Clear? Why this is called as real valued functions? Because domain is a real number set, codomain is also real number set. Either it can be a subset of the real number also. Clear? So that's why there are no that much of changes in the definition of previous definitions to this definition. Only the changes that defined by, that means in the definition you write let f be a function from R to R which is defined by f of x equal to, just that is the change. Clear? So how the polynomial is going to be, polynomial function is going to be defined here, let us see. So let f be a function from R to R. As you all know, R is a real number set and it is defined by f of x equal to a naught plus a1 x to the power of 1 plus a2 x square plus so on to plus an x to the power of n. Clear? So here what happens, a naught, a1 so on to a to the power of an are the real numbers, the coefficients are the real numbers, and n is non-negative. N is non-negative real number or non-negative number. That's all, non-negative number. Clear? So here we defined a function f from R to R, f of x equal to the polynomial in the variable of x where it ends at n. So a0, a1, a2 so on to an are the real numbers and n is non-negative number. Therefore the function defined in this form is called polynomial function. Clear? So you can say that let f be a function from R to R defined by f of x equal to a0 plus a1 x to the power of 1 plus a2 x square plus a3 x cube plus so on to an x to the power of n, where a1, a0, a1, a2, a3 so on to an are the real numbers, a0, a1, a2, a3 so on to an are the real numbers, and n is non-negative number, that is non-negative integer. If you want to specify, it is non-negative integer number. Clear? So if you define like this, this is called a polynomial function. So you must be very careful that while writing the definitions you have to mention everything, that is let f be a function from R to R, where is R set is called as real number set, f of x is defined by a0 plus a1 x to the power of 1 a2 x square so plus so on to an x to the power of n, and mentioning these things are very important, where a0, a1, a2, a3 so on to an belongs to R and n is non-negative integer. N is non-negative integer, so no problem. Hence it is called a polynomial function, or this such type of function is called as polynomial function, as you can write. Okay. So in this we take sub examples. Sub examples are f of x equal to x square. F of x equal to x square is one of the polynomial function which is having the graph nature as like this. Clear? So with the definition of polynomial function you can write an example, f of x equal to x square, and the graph of f of x equal to x square is like this. Okay. So again the same thing, f is a function from R to R defined by f of x equal to x square is called polynomial function. Clear? Because this is the example. This is the example for polynomial function. Whenever if they ask to define a polynomial function, you have to write this and you take an example of f of x equal to x square. And the nature of the graph is like this. Here the domain is real number set. The domain is real number set. No problem of domain. Next, codomain is also real number set. Codomain is real number set. Very specifying thing is range. So here, whenever you go through this type of function, range is very important, because if you writing, suppose if they ask to explain f of x equal to x square, or if they ask to write domain, codomain and range of f of x equal to x square, no problem with domain and codomain. Both are real number set. Okay, because this is a real valued function, that's why both are going to be a real number set. But what is range? See, the function is only upwards on the positive x axis. Okay, if it is on the positive x axis, means the range will be the positive real numbers union with singleton set 0. Positive real numbers with union of singleton set 0. Positive real number means it is only on the positive side. The graph is only on the positive side. That's why it will be a positive real number set union with singleton set 0, means 0 is also included. Clear? So that's why the range of f of x equal to x square is positive real numbers union singleton set 0. Clear? So let us look one more example for the polynomial function, then it will be very much clear. But before going to the example of polynomial, next example of polynomial function, first you please remember, if they ask to define the polynomial function, you have to write let f be a function from R to R, defined by f of x equal to a0 plus a1 x to the power of 1, a2 x square plus 1 to an x to the power of n, and a0 a1 so on to an belongs to R. This is very essential. Also n is positive integer. If you don't write this, no problem. You must write n is non-negative integer. N is non-negative integer, and here this is the one of example. This is one of the example. Clear? So for example, f of, you can write a function f from R to R defined by f of x equal to x square. Domain is real number set, codomain is real number set, range is R plus, that means the positive real numbers union with singleton set 0, and this is the graph. Clear? Okay students, now let us see the another example on polynomial function. Clear? So we already seen f of x equal to x square. Now let us see the next example. Clear? That is f of x equal to x cube. So what they are telling, draw the graph of the function f from R to R defined by f of x equal to x cube. Clear? So no problem, let us solve it. So for that you have to take some of the examples, so you can get the dots and you can join. Clear? So f of minus 1 will be what? Minus 1 cube, that is minus 1. F of 1 will be what? That is 1 cube, again it is 1. F of 2 is 2 cube, that is 8. F of minus 2 is minus 2 cube, that is minus 8. On the same way you can take f of minus 3, that is minus 27, and f of 3 will be 27, because they are telling f of x equal to x cube. Okay, so f of minus 1, x value is minus 1. In the place of x I will write minus 1. Minus 1 cube will be equal to minus 1. In the place of x I will take 1. 1 cube will be 1. In the place of x I will take 2. 2 cube will be 8. In the place of x I will take minus 2. Minus 2 cube will be minus 8. Okay. In the place of minus 3 if I take, you will get minus 27. In the place of 3 if I take x equal to 3, it will get 27. Okay. So from this, if you draw the graph, what you are going to have? See here. This is x axis. This is y axis. no problem. Let us take some examples on negative y-axis and on negative x-axis and positive x-axis, positive y-axis and negative y-axis. Let us take these examples. See, -1, output is -1. If I take x value as -1, output is also what? -1. So this is the dot. Clear? If I take 1, output is 1. Next, if I take 2, output is 8. If I take 2, output is somewhere 8. So I will take approximately, okay? Because we can't draw a specific diagram, so that's why I will take just some example. So -2, -8, somewhere here, like this. And 27, -27, here, somewhere I will take, this is +27. Clear? So if I join these dots, what you are going to have? You are going to have the nature of the graph like this. Clear? So this is going to be the nature of f of x equal to x cube. Okay, you can see this particular graph in the textbook also, so that the nature of the graph will be very much clear. But if they ask to draw this graph, you take this small examples and you can draw the graph. Clear? So try to do the homework of domain, codomain and range of this particular graph. Clear? Taken a homework of domain, codomain, that is homework is write the domain, codomain and range. Domain, codomain and range of f of x equal to x cube. These two are directly from f from R to R. If you know that, you can know what is domain and what is codomain. But range, little bit you have to think and answer. So that's why you do this homework, so that I will get a clear idea of that you are very much clear with the concepts. Okay, next I will go for rational function. Clear? Okay students, now next let us go for the rational function. Rational function. Clear? So here what happens, a function of the form or function defined by f of x divided by g of x, f of x divided by g of x. That means f is a function from R to R, g is a function from R to R, and a function defined by a function defined by f of x divided by g of x, where g of x is not equal to 0, where g of x is not equal to 0, and f of x and g of x are polynomial functions. Clear? So this type of function is called rational function. Clear? A function defined by f of x divided by g of x, a function defined by f of x divided by g of x, where g of x is not equal to 0 and f of x and g of x are polynomial functions. Clear? So if you see this type of function, then that function is called as rational function. Please remember, this is the function of the type p by q. Okay, or you can write it as equal to h of x also, no problem. Okay, but in the according to NCERT books, what they have given, we have to write, that is f of x by g of x, where g of x is not equal to 0 and f of x and g of x are going to be the polynomial functions. Hence, this type of function is called rational function. Clear? So, if they ask somewhere you to write a rational function, you just write a function of the form f of x divided by g of x, where g of x is not equal to 0. On the same way, f of x and g of x are the polynomial functions, is called rational function. Clear? So, if you write this much, this is more than enough. Now, let us see the examples on rational function. So, that's very important. Let us see the examples on rational function. Okay, students, you take this as a homework. Already this is a solved example in your NCERT textbook, and I have also said one of the PDF of your NCERT textbook, in that this problem is already solved. But before solving or before you referring that particular example, you try to solve it. After solving, you verify with that particular answer which is in your textbook. Clear? So here what they are asking, define a real valued function f r minus singleton set 0. That means in the domain there is no singleton set 0. That means in the domain there is no 0. Leaving 0, all the real numbers are present. Okay. So r minus singleton set 0 going to r, defined by f of x equal to 1 by x, that is a rational function. Complete the given table using this definition. That means this table has to be solved using this definition. For example, if I take minus 1 in the place of x, minus 1 divided by minus 1 will be what? Minus 1. Clear? Like that, you have to choose all the numbers and you have to simplify. You can use the calci also, no problem. Complete the given table using this definition. What is domain and range? So they are asking what is domain and range. So domain already you know here, and range by solving this you will get. Okay. And the nature of the graph is also given. So refer that nature of the graph also, so that it will be very easy to solve your range. Clear, students? You take this as an homework problem and try to solve it on your own. Don't copy from your textbook. First you solve, then you verify, so that you will be very much clear. Okay. So I will go for the next functions. Okay, students. Now let us move for the next example. Next type of function, that is signum function. That is signum function. Clear? So what is signum function? That is also very much important. So here what they say, let f be a function from R to R. Let f be a function from R to R, defined by f of x equal to positive 1 whenever x is greater than 0, 0 whenever x is equal to 0, minus 1 whenever x is lesser than 0. Clear? So the same function is also written as, or f of x is equal to mod x divided by x. See, what is meaning of this f of x? So f is from R to R, domain is real number set, codomain is real number set, and the signum function is defined as f of x equal to, into three branches they are going to define. What is your first branch? 1 whenever x is greater than 0, 0 whenever x is equal to 0, minus 1 whenever x is lesser than 0. Clear? So by solving this, what we understand here, for all positive real numbers that is greater than 0, the output remains same, that is 1. Whenever x is equal to 0, output is 0. Whenever x is lesser than 0, output is minus 1. So if you see the graph, see here, I will take this as positive 1, I will take this as negative 1. Clear? And this is 0. If I take x equal to 0, 0 is my output. Clear? See here, if I take x equal to 0, 0 is my output. So I will go through 0. If I take x is greater than 0, if I take x is greater than 0 at this point, somewhere at this point, what you are going to get the answer? You are going to get 1 as your answer. If I take here, you get 1 as your answer. If I take here, you get 1 as answer. If I take any number on this line, where is your output? Your output will be on 1. So that is nothing but the parallel line to x-axis. X greater than 0, parallel line to x-axis towards positive infinity. Next, if I take minus 1, it remains, sorry, if I take x is lesser than 0, again parallel to x-axis, it go towards negative infinity and the output will be minus 1. Clear? I can take any number from here. I can take any number from here. If I take any number, your output is what? Minus 1. It's not going to change. So it will be constant towards the minus 1. It will be constant on minus 1 and going towards minus infinity on the x-axis. Clear? So see this also. Whenever x is lesser than 0, it is on minus 1. Whenever x is greater than 0, it is on plus 1. Whenever x is equal to 0, it is on 0. Clear? So your domain is real number set. 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 And what about the range? See, guess what is the range here? You are getting only 3 outputs. 3 outputs. That is what? 1, 0, minus 1. These outputs are nothing but your range. So that's why range is going to be equal to 1, 0, minus 1. So this is your range for signum function. Clear? Let f be a function from R to R defined by f of x equal to 1 whenever x is greater than 0, 0 whenever x is equal to 0, minus 1 whenever x is lesser than 0 is called signum function. And the graph is like this. Nature of the graph. Okay. So nature of the graph will be like this. And range is 1, 0, minus 1. You can write this function as like this also. No problem. Either you write this or this. But my choice is please write this because it will be very clearful. And range is already given here. So that's why writing the range will be also very simple. If you write this, if you make perfect with this range, again you have to remember. Okay. If you make perfection with this, there is no need to remember the range. Directly these 3 numbers are going to be the range. So that's how you are going to write the range is equal to as 1, 0, minus 1 or minus 1, 0, 1. Clear? So this is called the signum function. Clear? So my dear students, we have came across with important functions like first identity function, next constant function, next modulus function. After that we gone through rational function. After that we gone through polynomial function, and now we are studying signum function. So in the rational function and the polynomial function, I have discussed some of the examples. So that examples you make sure that they are not going to be with any rough work. You make them in a notes, so that my intention is that things which you have written as example must be perfect. Clear? So now we have done almost most important functions. Now the remaining functions are greatest integer function, least integer function, and fractional function. That 3 functions are also very, very important. So those 3 functions I am going to cover in the next class. So there we are going to end all our some important functions. Okay. So in the next class I am going to start your greatest integer, least integer, and fractional functions. Clear?